Lesson 17.3, the effect of temperature on spontaneity. We covered earlier the delta H value of an exothermic process. An exothermic reaction, characterized by releasing heat into the environment, also increases the entropy of the surrounding, meaning that if delta H of a reaction is negative, then the delta S of the same reaction's surrounding will be positive. This is also true for endothermic reactions. Another way to find delta S of the surrounding would be using the formula delta S of the surrounding is equal to negative delta H of the reaction over the temperature in Kelvin. The temperature here has to be in Kelvin or else the answer will be incorrect. And to remind you, that is the temperature in degrees Celsius plus 273. The sign of delta S of the surrounding depends on which way the heat is flowing, whether it is endothermic, which would result in a negative delta S value, or whether it is exothermic, which would result in a positive delta S surrounding value. The magnitude also depends on the temperature, meaning if the temperature is higher, the delta S value will be significantly lower. This table basically simplifies everything we mentioned earlier to tell us whether the reaction would be spontaneous or non-spontaneous. If both the delta S of the system and delta S of the surrounding are positive, then it will always be spontaneous. If both are negative, then it will never be spontaneous. In fact, the reaction will actually occur in the opposite direction, most likely. If delta S of the system is positive, while delta S of the surrounding is negative, we can't for sure say that it would be non-spontaneous or spontaneous. It depends on the magnitude of each value, and if delta S of the system is negative and delta S of the surrounding is positive, the same goes for that. So for this question, they want us to predict whether the reaction would be spontaneous, non-spontaneous, or whether we don't have enough information to tell. In A, they ask for an exothermic reaction that becomes more positionally random. An exothermic reaction would have a delta S surrounding value greater than 0, and being more positionally random would mean that delta S of the system is also greater than 0. So this is positive, meaning this is spontaneous. If it is exothermic and becomes less positionally random, the delta S of the surrounding is positive, while the delta S of the system is negative. We don't have enough information to tell. To tell whether this is spontaneous or non-spontaneous, we need to look at the magnitude of each value, which we do not currently have. If the reaction is endothermic and becomes more positionally random, delta S of the surrounding will be less than 0, while the delta S of the system will be greater than 0. Since this is negative and this is positive, we also need the magnitudes of each value to tell whether it is spontaneous or not. If a reaction is endothermic and becomes less positionally random, both values will be negative, meaning this reaction is not non-spontaneous.
That'll be it for lesson 17.3, the effect of temperature on spontaneity. If you have any questions or want to ask anything at all, you can ask it down below in the comments section or on the server. If you want more videos like these or tutorials on any other subjects, you can find it down in the channel. And yeah, enjoy them.